Hello guys, welcome back. So here we have another question on communication system from GATEC 2023. So for a real signal, which of the following is or valid power spectral density or densities? So it is a MSQ question. So what is a power spectral density? So this is given as a mod of x of j omega whole square. So it is nothing but your square of your Fourier transform of the signal. So in this case, they have given the signal is real. So real means doesn't mean it is in real world. It means that complex, right? So complex has real and imaginary part. So real means your signal x of t is equal to x conjugate. So it has only the real part. Its imaginary part is 0 for all values of time instance. So based on this, we can derive few properties for your Fourier transform. So if you write out your Fourier transform, it is integral minus infinity to infinity x of t e power minus j omega t into dt. So try taking conjugate on both sides. So this is equal to minus infinity to infinity x conjugate of t e power j omega t dt. So now if you say x of t is real, so I can replace this with x of t, right? So x conjugate of j omega is equal to integral minus infinity to infinity x of t e power j omega t dt. So now I want to bring this to the form of Fourier transform. So for that I need a negative sign here. So what I'll do, I'll just change omega to minus omega. So then x conjugate of minus j omega is equal to integral minus infinity to infinity x of t e power minus j omega t dt. So this is nothing but your x of j omega. So this is the property we got. X conjugate of minus j omega is equal to x of j omega. So if I take another conjugate, I'll get x of minus j omega is equal to x conjugate of j omega. So these two things I have. So now I have my x of j omega square, which is nothing but my power spectral density. So this is nothing but x of j omega into x conjugate of j omega. So now using 1 and 2, my x of j omega is nothing but x conjugate of minus j omega, and my x conjugate of j omega is x of minus j omega. So now this becomes mod of x of minus j omega whole square. So what does it mean? X of j omega whole square is equal to x of minus j omega whole square. It means that if x of t is real, the power spectral density is even. We can also add purely real here. So this is the property which we derived. So PSD should be even. Can we go and check if that is the case for the signals? So here again it is even. Here it is even. Here if you see it is odd. So this is not the answer. Here again it is one-sided. So this is also not the answer. So other thing you should also consider is, since your x of j omega, like your power spectral density itself is an absolute value. So mod square, this is always going to be greater than or equal to 0. So it can never be negative. So here if you notice, both of these are always positive. So both these answers satisfy the given condition. So both of these are the answers.